Hey guys, so we are going to further discuss reliability, validity, and outcome measures. Up to this point, we have talked about reliability and validity within research, but it was in a general sense, and understanding and making sure that the research that we are praising is valid and reliable. Well, it's more than that. When you're looking at the outcome measures in research, we need to also know that those outcome measures are also valid and reliable. In order for research to be clinically useful, we have to know that the outcome measures used within the research is not only applicable to your patient population, but it demonstrates at a high quality and that's been proven. So before we appraise a few articles, because there are articles, of course, that research that are focusing on outcome measures solely. So we're actually going to this week appraise those type of articles. But before we do that, we need to, of course, have a discussion about outcome measures and reliability and validity. So let's just kind of start out with well, first, before I kind of go into the overview of reliability, I want to talk about the three main things that we're looking at. We're looking at reliability, and that refers to the outcome measures consistency and score production. We're also looking at validity, which refers to the outcome measures ability to measure the characteristic or feature that it is intended to measure. And then we are also looking at clinical meaningfulness, and that refers to an outcome measure's ability to provide the clinician, such as yourself, and your patient with useful information. We don't want to provide patients with false data, so that includes your outcome measures. You need to know that what was used as an outcome measure is appropriate for what you're looking at, and it's reliable, it's valid. We can trust that answer to provide to our patients and again use. So here's your overview of reliability. I've already stated what that is. Essentially, when we're looking at whether an outcome measure is reliable, we want to know that that measurement can be reproduced. That score can be reproduced, and that that score or that measurement is dependable. There are a few types of reliability, and I provide you with four here, which is test, retest reliability, rater reliability, intra-rater reliability, and inter-rater reliability. So test, retest reliability, and I should probably also add internal consistency, which we'll talk about on the next slide. But these two quantify the consistency of the measure itself. So we're looking at the measure itself. While rater, intra-rater, and inter-rater reliability, we're looking at the raters who actually conduct the test. Now let's just make a simple note of the difference again between intra and inter. Inter is simply looking at one assessor over multiple trials, while inter is looking at two or more raters over the same trial. And it's important to note that before we can establish inter-rater reliability, we need to know that there is intra-rater reliability. So each rater should have been assessed individually before we would make comparisons between the two. We wouldn't just go straight to inter-rater reliability. So, as I said, I should have probably included internal consistency in the other slide, but essentially internal consistency establishes the extent to which multiple items within an outcome measure. So the example that I provided is just in a general context. So if you're assessing a patient's ability to perform daily tasks using a physical function scale, then the items on that scale should relate to the aspects of physical function only. If items such as social characteristics are evaluated as well as physical function, well then it's not homogeneous, and we're looking for homogeneity. when we're looking for internal consistency. Your book gives an example of looking at the Berg balance scale. So we know that the Berg balance scale consists of 14 items, right? And it's intended to measure one construct, and that construct is balance. So in order to determine internal consistency of this scale, we have to look at inter-item correlation. And just to bring you back to a statistical relationship, or a statistical mindset, I want to also provide you with a statistical relationship, and that is providing you with the statistical test that is used to determine internal consistency, and that's the Cronbach's coefficient alpha. So with that, when you're looking at inter-item correlation, okay, it's going to give you a score that ranges from 0 to 1. If you get a score that is close to 0, then that essentially indicates that the individual items of the measure don't correlate with each other. But if you get a score that's closer to 1, then that indicates that the items have strong correlation. And your book goes into a little more detail about this, but again, I kind of want to keep it as an overview because you'll read your chapters regardless. So, when we are looking at reliability of an outcome measure, we are also looking at generalization. Okay, we are trying to provide a frame of reference for interpretation of reliability coefficients, and suggest areas of improvement for protocols. Okay, so essentially, measures of reliability can be generalized. And the example that I provide is testing the grip strength of a patient with RA using a hand dynamometer. If you have a single measured score of 15 pounds, this could be one of a universe of possible scores. Okay. However, or I should state that, if you're obtaining this under the same testing conditions, using the same tool at the same time of the day and by the same examiner. But we're taking this in small samples, so each number or each sample is a single measurement that becomes the best estimate of a true score under those conditions. So generalization, reliability should and can be generalized. And essentially that's the most that you really need to take from this slide. But I wanted to add it in there because it's important. Moving forward, I'm going to introduce, or not necessarily introduce because we've talked about a few of these, but discuss some things that we're looking at where we're looking at outcome measures. And minimal detectable difference is one of them. MDD defines the amount of change in a variable that must be achieved to reflect a true difference. This is the smallest amount of difference that passes through the threshold of error for a specific instrument and application. The greater the reliability of the measurement, the smaller the MDD. So if you get, if you're appraising research for an outcome measure and there's a large MDD, well, that's something to question. But if it's showing you that the MDD is small, then that produces reliability or greater reliability. So what to take from this is probably the bottom half, because that's what I really want you to understand. In a study of association, it is the smallest change in the dependent, which is the outcome variable or response, per unit change in the independent variable that is plausible. And this is something to remember. And actually, I want you to remember the following ones as well, because these are things you may also look at when you're focusing on your single subject research. These are things that you may incorporate Um, the next one that we are going to look at is minimal detectable change, which is MDC. And I should add that, MDD, MDC, and another one that we're going to look at, which is um, responsiveness and minimal clinically important difference. These are all looking at studies that assess outcome measures' clinical meaningfulness. And these essentially are different types of clinical meaningfulness. So that's another reason why they're important. So back to this slide. MDC is the minimum amount of change required of an outcome measure to exceed anticipated measurement error and variability. So a great example of this is the 6-minute walking test. So let's say you have a patient, and every day for however many days you're recording a score, and you're looking at this patient and you're completing this assessment. Okay? You would expect that there should be some change when doing this daily with the same patient. However, in order to understand the extent of the variation or that change, you need to know how much change is needed in the first place. And that's what the MDC gives you. This change is derived by using an outcome measures retest reliability, and within subject standard deviation for a repeated measure, because you would be repeating this test over and over and over to identify change. Responsiveness reflects an outcome measure's ability to detect change over time. So going back or using the example that we just used for the 6-minute walk test, if you're completing this assessment every day, you would expect to see some response to the assessment in the patient's status. And that is what you're looking at. You're looking at usually quantitative studies, and you're looking at data over a period of time and a change in the patient's status. Okay? So if your patient improves in a particular characteristic, you would want to know that measure you are willing to detect or respond to that change. So, I guess I should go to the next one because it would make more sense. So, one measure of responsiveness that is used is the minimal clinically important difference, which I do have at the bottom. Okay, so it's the very last point here. This is also referred to as the minimal important difference, which MDI, so MCDI or MID, I'm sorry. And it represents the minimal amount of change of an outcome measure that patients perceive as beneficial, and that would justify a change in care. So it answers such questions as how much change on an outcome measure is enough to be meaningful. Note that this is different than minimal detectable change. Okay? Because we want to essentially know, in a clinical sense, what is enough of an outcome for it to be considered important, for it to be considered beneficial for your patient, and to be considered or justify change in care. And then two others that I've added at the top, I know I'm going out of order, is floor effects and ceiling effects. So floor and ceiling effects reflect a lack of sufficient range in the measure to fully characterize a group of patients. So if you consider an outcome measure that is designed to measure adults' fine motor control, you could have possible scores that range from 0 to 10, with higher scores indicating better performance. However, when you're looking at the chart or the graph, if you start to see trends in the data, then that's something to consider. So, and that's what gives you the ceiling or floor effect. If you have a ceiling effect, and I'm using these two examples as a very broad example, but I want you to understand, and I feel that using this would be easier to understand. So if you have a floor effect, this occurs when like an examination is too difficult and most of the examinees score very low. So let's say I was to give you a very hard test and everybody scored low. That's a floor effect, okay? Because all of the data points or your scores would be at the bottom of my graph. A ceiling effect happens when it's the complete opposite. I give you a test and it's too easy, so everyone has 90s and 100s, so all of the scores are at the top. Well, the measure should be appropriate for use among, or the measure should be appropriate for what you're looking at. So it shouldn't necessarily all be very high or be very low. Um, it's unusual to see a study that is specifically designed to study ceiling and floor effects, but it is common to see this within studies that discover these effects as a part of a larger study. So these are things that you often do look for, and the usefulness of a measure is diminished by the presence of these effects, whether they be floor or ceiling. Okay, so let's talk now about validity. So as I mentioned to you earlier, validity refers to the measure relevance to underlying construct, or I should say the construct it is intended to measure. So what is being measured is measured and it's valid. So if you're, looking at patients who have, let's say, adult patients with depression, you want to know that the outcome measures that you're using are actually identifying depression. And as the same as reliability, there are a number of types of validity, and each study may use a different one or may use a couple. But when you're looking at articles and you're praising these articles of outcome measures, there should be information, or they should tell you about the validity and the types of validity that were used. So the first one that we are going to look at is face validity. And face validity is based on informal evaluation by experts that a measure appears to measure what is intended to measure. So if you decided to measure patient satisfaction in your clinic, you would develop a questionnaire that asks patients about their satisfaction with therapy. If you and others who work with you in your clinic believe that the survey addresses patient satisfaction, you could consider the survey to have face validity. Okay? You could enhance the face validity by asking current and former patients if they believe that the questionnaire actually and sufficiently explores their satisfaction as well. I've added some additional notes here. So examples where you would see face validity could be attributed to tests such as range of motion, length, strength, tactical discrimination, sensation, gait, and balance. And then it can be used to look at separate items of a functional status scale, like eating, dressing, transferring. The thing about face validity, though, is that it's not the strongest of all the types of validity that are available, and sometimes it is considered scientifically weak, but that doesn't mean we disregard it. If you end up, or I should say if a researcher, as a researcher, if that's the only plausible form of validation that you have, then we do take it into consideration. So it's not useless, it's just not the first choice always. But again, like I said, the type of validity that is used is dependent on the study. The next one that we're going to look at is content validity. Content validity establishes that an outcome measure includes all the characteristics that it is supposed to measure. So, if an outcome measure assesses activity limitations associated with low back pain, a study of content validity would attempt to establish that all aspects of that activity might be affected by low back pain are essentially included. And I also give you another example here using gross motor skills. But whatever you're measuring should reflect that construct that you're looking at. Okay? Next we have criterion validity. This establishes the validity of an outcome measure by comparing it to another. So it would be compared to an already established measurement. And most importantly, it would be compared to a gold standard, something that's considered the best. The example that I provided is if you're looking at validity of a heart rate as an indicator of energy cost during exercise by correlating its values obtained in standard oxygen consumption studies, that would be your criterion measure. We would establish validity of observational gait analysis, that's the test target, by comparing results with those obtained with computerized motion analysis systems, the criterion measure. So I guess the key thing to take from this is that, and this is one that you'll see often. So the criterion validity is a test or target test that is compared to a gold standard to prove whether that test target is valid or not. It's going against something that's already been proven valid. Alright, next we have concurrent validity. This is established when researchers demonstrate that an outcome measure has a high correlation with the criterion measure taken at the same point in time. So they kind of work together. And then an example that I gave is an autism screening questionnaire was developed to distinguish children with autism and pervasive development disorders based on a parental interview as a reference standard. Okay? And often you'll see this used with diagnostics or screening tests when you're looking for determining the presence or absence of diseases or conditions. And I apologize down here, this is what I was reading. I need to correct that, so I will make sure that's corrected before I actually provide the slides. Next we have predictive validity. This is established when researchers demonstrate that an outcome measure has a high correlation with future criterion measure. So an example for this is if a new measure of balance has high correlation with falls experienced by an individual over a period of 1 year, the measure would be considered to have predictive validity for falls. Or another example that I wrote down here for you is the Berg Balance Scale or the timed up and go test can be used as a screening tool to predict risk falls for elderly individuals. Results of screening tests allow clinicians, such as yourself, to initiate appropriate preventative strategies. So it's useful for screening procedures to assess future risk. And again, I apologize. I see another error, which I will fix by the time you get these as actual slides. Okay, so this one is a little bit more difficult. Actually, construct validity is one of the more complex forms of validity to establish because it's based on, well, it's assessing a characteristic or concept. So to establish construct validity, outcome measure developers have to provide a theoretical model that describes the constructs being assessed. After that, a series of studies are then conducted to establish whether the measure actually assesses those constructs. So this is like the theoretical framework of how an outcome measure is developed and then tested. Okay, and then there are three groups that I did not describe in the slides that are used to help establish construct validity, and those include known groups validity, convergent validity, and discriminant validity, but your book will go into a little more detail about that as well. So the only one that I did put on here is, of those three, is convergent validity, which establishes that a new measure correlates with another thought to measure a similar characteristic or concept. And then in that case, discriminant measure would be the opposite of that. So the example that I provided, that if two health status scales are valid methods for measuring quality of life, they should produce correlated scores. So bringing the two back together, there are always issues of concerns when you're looking at reliability and validity, and that's one of the reasons why we are praising the articles and the research. The measurement error is examined in terms of judgments rather than numerical equivalency, and the data sources are words rather than numbers. Okay, terms and techniques are used to describe and determine trustworthiness, credibility, and truth refer to internal validity. Transferability refers to external validity, while consistency and dependability refer to reliability. And the approaches reflect the need to consider rigor of data analysis and potential for investigative bias. Now, the only thing, or the last portion that I didn't actually include in this, because there are a set of questions that I would prefer you read within your text, and that is the appraising, actually appraising the studies for quality and validity. However, I did provide the two tables for you that have the questions that you're going to look at for reliability and validity, so that you have this as a source when you get ready to appraise the articles that I provided for you. So make sure you take a peek at 10.6, which is on pages 132 and 133, as well as table 10.8, which is pages 136 to 137. This is all in your Fetters and Tilson's text. But these tables provide exact questions of what you're looking at when you're appraising studies of validity and reliability. As always, if you have any questions, don't hesitate to email me or message me or Skype me if you need to discuss any of this in further or in detail or furthermore. Thanks.